Welcome to episode 13, Exploring Sine Wave with the Accounts. We have been watching accounts respond to input signals. Let's now focus on inputs that happen again and again. A very simple version of this is giving an account a dose of positive value, then a bit later giving the account a dose of negative value. What will the account do? We see square wave. Once each dose of value is delivered, the account sits at its new level until told to assume some other value. Now let's follow one account with the second account. Our square wave has been changed to triangle wave. This is what we would expect. We have fed constant value to accounts before and seen ramping behavior on account outputs. I am taking the liberty of doing some amplification and offset control between the accounts to keep the signals centered on the graph page. But this doesn't change our story of how the wave type changes after each added account. Now let's follow the second account with a third account. What will it do to triangle wave? We look pretty smooth now. That seems to be what the accounts are good at. Fewer sharp corners each time as we add accounts. What comes after smooth wave? Smoother wave? What does that mean? We add a fourth account. Here is the result of additional smoothing of an already smooth wave. Not much to see in overall appearance. But there is a difference. Check out the start time. The wave of the fourth account is delayed with respect to the output of the third account. Does high school algebra have anything to say about what we have been doing? Yes. The flat lines of the square wave are segments of x to the 0 power. The sections of triangle wave are segments of x to the first power. The sections of our first smooth wave are x to the second power or pieces of parabola hooked end-to-end with alternating sines. So the output of the fourth account should be pieces of cubic wave hooked together with alternating sines. We have been making a crude attempt to approach sine wave step by step, and this could go on for a long time. So now we will jump to the real thing as there are no more big ideas to come from just adding more accounts to our pulse generator. The simulation program has a true sine wave generating block and we will start using it now. We first run real sine wave into one account. We get our quarter cycle of delay. We can call this 90 degrees or pi over 2. Now we run two accounts and get 180 degrees or pi of delay. 3 accounts gets us to 270 degrees or 3 pi over 2 of delay. 4 accounts. We are now back in phase with the generator. We have made one full trip around the trigonometric circle. The fudge amplifiers are gone from the setup screen. They are not needed. The accounts recognize real sine wave and don't lose any amplitude from one account stage to the next. All I have to do to keep signals from floating up or down the page is give the accounts the proper starting levels for their phase position. These are simple to figure out. They can only be 0, -1 or +1. Pure sine wave is one of nature's great simplifiers. Now a leap of faith. Since 4 properly preset accounts produce exactly the same wave as the generator, do we need the generator at all? Let's hook the tail of a 4-account chain back to the head and see if sine wave happens by itself. It does. What are we simulating? Perhaps a ball rolling on a smooth table without resistance. Perhaps the seasons of the year. But this is kind of artificial. Nature doesn't have many of these 4-account chains in the wild. Let's look at our signals carefully and sleuth out what nature is more likely to be doing. What is the difference between the output of accounts 2 and 4? One is the mirror image of the other. Do we have a non-account, non-time-dependent, purely algebraic mirror image function block? Yes. A simple inverter. A simple multiply by -1 function. Can we use this inverter to get rid of 2 of the accounts? Success. It runs just as well as the 4-account chain. Now we are doing what nature usually does. We are simulating the drama of two of nature's role players responding to one another with a mix of positive and negative feedback, with competition, if you will. This is the most basic harmonic oscillator. People build them with transistors in the lab and animals build them in the forest when a predator species overhunts a prey species. In the remaining episodes, sine wave generators will rule. They are literally everywhere across all the parts of nature and society that we watch. See you next time for car suspension. How does a car provide a soft enough ride but avoid wheel hop and loss of control? Scilab is software buy-in for the world's community. Help them with dollars, publicity, and contribute code. TTS Voices copyrighted 2014 and licensed by LinguaTech, GmbH. Visit them at linguatech.de. Text and graphics copyrighted 2019 by William Rhodes Design.